Okay, so next we consider the mean of a frequency distribution. But before that, I want you to understand the difference between group data and ungrouped data. Well, ungrouped data is raw data. So when you collect information from any observations and you record that information, it is recorded in an unorganized form. It is actually recorded in a very random form. So you convert that unorganized and ungrouped data into frequency distribution. So frequency distribution is a form of grouped data. Remember, we make classes. So why we make classes? We make groups of classes. So these groups or classes, they make the data or convert the data into group data. So when we have group data, for example, if you study research papers, so research papers don't provide you the raw data. You are only given the frequency tables, and sometimes it's very difficult to contact the author of the paper, or it's not, very easy to access, to have an access or a request and access towards the data. So what you can do if you want to calculate the mean of the frequency distribution that is given in the research paper, then we use this formula. Now consider X here as midpoint. And I think you already know about midpoint, because when we were preparing the polygon graph, we calculated midpoint. So let's see an example. So again, we have data for 30 people, and we have classes for them. And we also have midpoints for these classes. And then we have frequency for each midpoint. So for every midpoint, we multiply that with the frequency of that class. And we get these products that we sum up. And what we have to do now, we have to divide it by the total number of observations, where we get that the total frequency is the total number of observations. So we have a total of 909, and that is divided by 30. And what is the answer? 30.3. So 30.3 is the answer. And what is this answer? This is mean of this data set. Okay, so if you have the ungrouped data, your mean can be slightly different, but only slightly different. You will see that this is very close estimation of the actual data. All right, so make sure you understand how to calculate the mean for group data. Okay, next we discuss the shapes of distributions. What is a distribution? If you remember, we prepared a histogram, and the bars were actually conveying a specific type of distribution of different classes. And we also call the table of frequencies frequency distribution, because we distribute the frequency between different classes. So there can be multiple shapes. For example, the data can be symmetrical. Okay, the data can be uniform. The shape of the distribution can be uniform or rectangular. It can be skewed, but it can be skewed in two ways. It can be skewed left, which is called negatively skewed, or it can be skewed right, which is called positively skewed. Let's see. For example, if you look at this data, this is a very symmetric distribution. This is the perfect symmetry that we can see. If you draw a polygon curve in the midpoints of these classes, you see this kind of a curve, which is reflective on both sides of the mean, right? So in the center, you have mean, median, and mode, and on left and right side, you find the same reflection of data. Okay, so when we have a symmetric distribution, you will see the mean and the median and the mode, all three of them will fall at the same place. So this is symmetric data, and in the exact center, you see that you have the highest frequency, that is the mode, and the median is also the exact center of the data. So median also falls here. And if you calculate the mean by summing up all these values and dividing by the number of values, you will see the mean is also the same value. All right, so, but it can be left skewed, right? Now, if you make a polygon curve here, you will see that the curve would be like this, right? So the left tail is a little stretched. You have most of the values falling on the right. So where you have most of the values, that is the point where you have the mode. Okay, and because most values fall towards the right, next to the mode you will find median. And because of these extreme values here, the mean would be a little bit stretched towards the left. So mean would be here. So as you can see in the graph, because since it is increasing with the time, or if you look into the data, it is increasing. It is showing you an increasing trend, and that trend shows you that there is a left skewness, that most of the most of the values, they fall in the right end of the data. And as you can see, for this data set, the median would be greater than the mean. So median is greater than the mean. And again, the reverse can be seen in a positively skewed. And if I again draw the polygon curve, you can see that the right tail is a narrow tail, whereas most of the values fall on the left side. So you will have your mode here, then median, and then mean. Why mean is to the right? Because of these extreme values. They have stretched the mean towards themselves. They have pulled the mean towards themselves. So here you can see that mean is greater than the median. Mean is on the right. That means there is a higher value for the mean as compared to the median, and the median is greater than the mode. Okay, so symmetric shape we just described, we saw if the data is like this, that all the elements of the data set, they have exact values, you will have a uniform or rectangular distribution. So we have seen the right skewed distribution, and we have also seen the left skewed distribution, right?